So 2022, paper 2 deferred, and this is question 4, part A. So it says the diagram below shows a triangle ABC, not to scale. In other words, you can't measure it to do anything with it. You have to calculate. The coordinates of each point are given. So it says, show that the circumcenter of the triangle ABC is the midpoint of AC. So I suppose first we probably need to recap on what exactly is a circumcenter. So circumcenter, we need to think about this for a moment. So it's a point that is equidistant from all three vertices. Another way of talking about it is you can say that it is the point where the triangle's three perpendicular bisectors intersect. So there's a few ways you could actually approach it for that reason. So, for example, you could get, because it's perpendicular bisector, you could get the midpoint of each line, get the perpendicular slope, get the equation of that perpendicular bisector, and then do simultaneous equations on the lines that that intersect each other. I feel that would be quite a long way of doing it. Might be interesting to do two different ways for your own sake, but I suppose bearing in mind we're in an exam and we want to get through it and as painlessly as possible. So I think a good option here is that it says we're trying to show that the midpoint of AC, so that the very middle of AC, wherever that is in fact the circumcenter. So if we find out what the midpoint is, then we should be able to show that it's the same distance from there to there, from there to there, and from there to there. And if it is, then we're confident that it is the circumcenter. So I think that's a kind of a more straightforward approach. So 8, 4 minus 3, 2. So that's my A and C, x1, y1, x2, y2. My midpoint formula, page 18, x1 plus x2 all over 2, y1 plus y2 all over 2. So I have x1, 8 plus x2. Now it's plus minus, so it's minus 3 all over 2. And then I have y1, which is 4 plus 2 all over 2. So I end up with 5 over 2. And I end up with 6 over 2, which is 3. So I end up with basically 2.53. Now, in my diagram, I mean, I kind of had a stab at it. I was a little bit off. So there is where it actually is. So what I'm going to do now is I'm going to get the distance. So I'm going to get the distance from 2.53 and either A or C. So I might just do A, I guess, seeing as there's no negatives. So what I'm going to do is I'm going to find what this distance is, x1, y1, x2, y2. I'm going to use my distance formula, x2 minus x1 to be squared plus y2 minus y1 to be squared. So we end up with 8 minus 2.5 squared plus 4 minus 3 squared. So we end up with 8 minus 2.5. So what's that? That's 5.5. So we end up with 5.5 squared plus 4, take 3 is 1, 1 squared is 1. So I'm going to do the square root of, so I'm just going to pop this into my calculator, 5.5 squared plus 1. Now, I am getting the distance to be, so it's in third form, it is 5 root 5 over 2. I can change it to a decimal either, and I'm getting 5.59. Now, that is the distance from the midpoint, we'll label that M, over as far as A. Now, we can automatically assume M2, the other side, which is C, is also 5.59. And the reason I'm allowed to assume that is because m is the midpoint between them. So obviously if it's in the middle, on either side, we have the same distance. But the key element is the 2.53, is that also 5.9 from the remaining coordinate? So my remaining coordinate is 5,8. So I'm going to put 5,8 there. And I'm going to do exactly the same thing, x1, y1, x2, y2. I'm going to put it into my distance formula, just maybe speed this up a little bit here. So that's 5 minus 2.5 squared plus y2 minus y1 to be squared. So I end up with 2.5 squared plus 5 squared. So 2.5 squared plus 5 squared, which is 25. So I end up getting 5.59. Now, because they are all the same, so that's B. It was B, wasn't it? It was. So MB. So what I've now found is that the distance from M to A equals the distance from M to C equals the distance from M to B. Therefore, it is the circumcenter. Okay, that's it.